Alright, and we're back for lesson 68. We're talking about the probability multiplication rule. And your objective is right here. Write it down. And then we'll get started here. First thing that we need to know is definition here. Independent events means that if more than one thing happens, the first event does not affect the probability of the next ones. Okay, so for example, if I roll the die once and roll the die again, the first thing that happens does not affect the second thing. So I could roll a 1 the first time, and that's not going to affect at all what happens with the second roll. I could still roll a 1 again or whatever else, just as likely. If I flipped a coin twice, okay, those are independent events, because if I flip the coin and get heads once, then that's not going to affect the second flip. Okay? Whereas let's say I had a bucket of Jolly Ranchers, okay, and I told you to draw one out, and I want to know the probability of you getting a blue, a red, a green, or whatever colors there were. Okay? Well, if I take one out and get a blue one and don't put it back in, then that affects the second draw. Okay? If I took out another Jolly Rancher, and the more I take out, the more that it affects what's going to happen. So those are not independent events. Okay? So independent events means the first thing that happened does not affect the probability of the second. Now, let's look at something else here. Let's talk about sample space. So if I flip a coin twice, okay, with flip 1, I can get heads or tails. Okay? And then with flip 2, okay, I could get heads or tails again. And same thing here, I could get heads or tails again. So if I get heads the first time, I can get heads and tails the second time. And if I get tails the first time, I can get heads and tails the second time. So my sample space is heads and then heads, or heads and then tails, or tails and then heads, or tails then tails. When I have independent events, if I want to know how many outcomes there are, okay, how many possible things can happen, well, if I look here, I've got 1, 2, 3, 4 things that can happen when I flip a coin twice. Okay, and the quick way to do that is figure out how many things can happen the first time I flip. So the first time I flipped, there are 2 possible things that can happen. And with flip 2, there are 2 possible things that can happen. I can get heads or tails either time. Well, notice that if I take flip 1, the possible outcomes, there's 2 possible outcomes, times the number of outcomes in flip 2, I get the total number of things that can happen here. Okay? So if I want to know how many outcomes there are when I flip a coin twice, I take the number of outcomes in flip 1, which is 2 possible outcomes, and the number in flip 2, 2 possible outcomes, right here, and I get my 4 possible outcomes total up here. Okay, so let's look at example 1. It says, how many possible outcomes are there for an experiment which has 2 number cubes that are rolled together? So I want to know just how many different things could happen if I rolled 2 die. Okay, so I can have die 1 and die 2. Okay, now how many possible things can happen when you roll a die? I can get a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 possible things that can happen when I roll die 1. And same thing with the second die, there are 6 possible things that can happen. What I'm going to do to figure out the total number of outcomes, things that can happen, is I'm going to multiply those together. And I'm going to get 36 possible outcomes. Okay, now we could make a table to validate that. I mean, I could roll a 1 and then a 1. Okay? I could roll a 1 and then a 2, a 1 and then a 3, a 1 and then a 4, and so on. I could roll a 2 and then a 1, a 2 and then a 2, a 2 and then a 3. It would take me forever to count all those out. So this rule right here, the multiplication rule, is a quick way to figure out how many possible outcomes there are. There's 6 things that can happen in the first die, 6 things that can happen in the second die. I multiply those together to get 36 total outcomes. Okay, now let's go ahead and explore this multiplication rule a little more. Example 2 says 2 number cubes are rolled once. How many possible outcomes are there for which the first roll is even and the second roll is even? Okay, so I want to know how many outcomes for the first roll being even and the second being even. And we're going to take these and multiply them together here. Well, think about when I roll a number cube again, a die that's 1, 2, 3, 4, 5, or 6. How many ways are there to get an even Well, my evens are 2, 4, and 6. So that's 3 possibilities. And if I want the second roll to be even, again, there are 3 possibilities. So I'm going to take those and multiply those, and that means there are 9 different ways, or 9 outcomes. Okay, 9 different, whoops, I should say outcomes here. Let's erase that. There are 9 different outcomes, or 9 different ways that I can roll an even 2 times in a row. Okay? So for example, I could get, let's say, a 2 and then a 2, a 2 and then a 4, a 2 and then a 6. I could get a 4 and then a 2, and so on and so forth. And there are 9 different ways. Okay, but again, the quick way to figure that out is to find out how many different ways the first time, how many different ways the second time, and multiply those together. Okay, now let's move on to a couple different types of examples. Example 3 says, suppose a bag contains 2 red and 3 blue marbles. Robert selects a marble from a bag, looks at it, and then replaces it. Okay, so that means that he takes it out, figures out what it is, and then puts it back in. Then he selects a second marble from the bag. What is the probability he selects a red marble and then a blue marble? Now these are independent events, meaning the first one does not affect the second one. And the reason is because once he takes the marble out, he's putting it back in. So there are just as many marbles on his first draw as the second draw. And the third draw, there would be just as many marbles if he puts it back in. Okay, whereas if he takes it out, he's got 1 less marble each time. That's not independent events anymore. Okay, so this is an independent event, and when we have independent events, it's really easy to find the probability. Okay, there's a really easy rule we're going to use here, where we're going to take the probability of the first event and multiply it times the probability of the second event. Okay, this works for the probability of independent events. Probability of independent events, we take the probability of the first times the probability of the second. If we did it a third time, we'd multiply it by the probability of the third event. Okay? So, suppose his bag contains 3 red and 2 blue marbles. He selects marble and looks at it. What's the probability that he selects a red? So we want the probability of a red. And we're going to multiply that by the probability of a blue. Whoops. By the probability of a blue. Okay? Well, the probability of a red is the number of red over the total. Okay, so there are 2 red out of 5 total marbles, because 2 red plus 3 blue equals 5 total. So he's got a 2 out of 5 chance of drawing a red. We're going to multiply that by the probability of a blue. Well, if he puts the red back, that means there's going to be 5 marbles in there again. And out of those 5 marbles, there are 3 blue ones. So I'm going to take these numbers and multiply them together. Well, if I multiply across the top, 2 times 3 is 6. On bottom, 5 times 5 is 25. So the probability that he selects a red marble and then a blue marble is 6 out of 25. So 6 out of every 25 times he does this experiment, he should draw a red and then a blue. Okay, that means a red, blue, and a first, second. And again, this number, if we can, we would reduce it, but there's no number that goes into 6 and 25, so we leave it. So again, probability of independent events, okay, means we're going to multiply the 2 probabilities together. Now let's go ahead and look at one last example. It says Maribel holds a stack of 52 alphabet cards. She's got 26 uppercase cards, meaning capital letters, and 26 lowercase cards. So she's got 1 uppercase or 1 capital letter for every letter of the alphabet and 1 lowercase letter for every letter. She shuffles the stack and selects 1 card. It says, what is the probability that is an uppercase vowel? Okay, so we want to know the probability that this card is uppercase and a vowel. Okay? Well, let's think about this. What's the probability of her getting an uppercase card? The probability of an uppercase is the uppercase cards, which is 26, out of the total cards. Well, there are 26 uppercase and 26 lowercase, that's 52 total cards. And the probability of her getting a vowel, okay, these are 2 completely different things. Uppercase and a vowel are 2 different things, so they're independent events. We're going to multiply them together. the probability of getting a vowel. Okay, well, let's think about how many vowels there are. Vowels are A, E, I, O, and U. Okay? So there are going to be 5 lowercase vowels, and there's also going to be 5 uppercase vowels. So that means there's 10 vowels total out of the 52 total cards. Okay? And we're going to multiply these together. Well, the very first thing I would do is reduce them. Okay, 26 and 52 will reduce. 26 goes into 52, exactly, and it goes in there twice. Okay? Well, 10 and 52 can reduce. 2 goes into both of those, so 10 divided by 2 is 5, and 52 divided by 2 is 26. So now I'm going to multiply on top. 1 times 5 is 5, and on bottom, 26 times 2, 52. And 5 out of 52 will not simplify. So the probability of an uppercase vowel is 5 out of 52. We take the probability of it being uppercase and the probability of it being a vowel and multiply those together because those are two completely separate things. Alright, that's your lesson on independent probability and the multiplication rule. Happy homeworking.